Hello students, welcome back to IISc Academy. This is Virena. So today let us start the new topic, that is vector calculus. So guys, before starting the vector calculus, let us know about the operator, that is del. Del, or it is also known as the nabla. Now, what is the del operator? It is nothing but dou by dou xi plus dou by dou yj plus dou by dou zk. Means it is just the operator. You can use it in three ways, right? That is, you can use it either to a scalar function f, that is gradient of f. In between there will be no dot like this, cross like this, right? Either you can use the dot product or cross product, or just apply the operator to the scalar function f. Here f is the scalar function, this is the vector, this f bar, that's why it is written as f bar, right? F bar is the vector, this f bar is the again a vector. This is the scalar function without the I, j, k values. Means directly it is like a equation like this. F equal to x square y plus yz cube. This is a scalar function. Now f bar means what? F bar means it is like xzi plus yx square k plus z, this is j plus zk, like this. If there is I, j, k, you know the vector representation, right? So that will be a vector function. So without them, whatever is present, just the function of x, y, z, that will be a scalar function. So now, when del is applied to a scalar function, that is del f, which is known as gradient of f. What is the meaning of gradient of f? So gradient of a scalar function, it always converts scalar to a vector. This function is a scalar function. After applying the gradient, right? So this one, this operator, we will see how to apply this one to a scalar function here with an example, right? So after applying the gradient, that is del operator, to a scalar function, it will convert the scalar function to a vector function. F is a scalar, but del f is a vector, right? Now, if there is a dot product here, del dot f bar, that is divergence. This is known as the divergence of f bar, divergence of a vector function. It will convert a vector to a scalar. F bar is a vector, but divergence of f bar, that is del dot f bar, is a scalar function. Now again we will be seeing how to apply these operators later, one by one with an examples. Now this is del cross f bar, the cross product of two vectors, correct? Del cross f bar. Here also f bar is a vector. Now what about the del cross f bar? It will also be a vector only. Always cross product will give us the vector as the result. Dot product will give us the scalar as the result. Gradient will give the vector as a result. So curl of f bar, this is also known as the curl of f bar. Symbolic representation is this one, del cross f bar, known as the curl of f bar, curl of a vector function. Always curl is applied to a vector function only. Now curl converts vector to again vector, because f bar is a vector, curl of f bar is also a vector function. Understood? Now one by one we will be seeing how to apply these operators individually, right? So let us see here. The gradient of a scalar function f of xyz. This is a scalar function. The function of xyz is defined as, how to define the gradient? The gradient operator, when you apply it, gradient of f, this becomes the dou f by dou xi, because what is del? Del is this one. So you are applying the f, this one, gradient of f, gradient of a scalar function. So write dou f by dou x, dou f by dou y, dou f by dou z k, like this. So dou f by dou x I, dou f by dou y j, dou f by dou z k, that is fx. You can also, in short form, you can call it as f subscript x, like this. F subscript x means what? Dou f by dou x, that is partial differentiation of f with respect to x. This is partial differentiation of f with respect to y and partial differentiation of f with respect to z, that is fz, you can call it. So let me take an example. F is equals to x square y plus yz cube is there here. X square y plus yz. This is a scalar function, not a vector, right? Because it is just a function of xyz, f of xyz, like this. Now how to find the gradient of this function? Apply the gradient of operator. Gradient of f equals to del f, nothing but fxi, this is this one, fxi, fyj, fzk, right? Now what is the fx? Means for this entire function f, partially differentiate with respect to x alone, treating other variables as constants. Means when you are differentiating with respect to x, other variables are what? Y and z. They will be treated as the constants. So what is the difference with respect to x? This becomes 2xy, because y is a constant. Constant into x square differentiation is what? 2x into constant. So 2xy. So that's why I written 2xyi. Now fyj. What is differentiation of this function with respect to y? So this becomes only x square, because constant into y, right? Because when I am differentiating a function with respect to y, the other variables, that is x and z, are treated as the constants. So that is why here x and z I can treat as constants. So x square y differentiation will be x square only, and y z cube differentiation is what? Z cube only, right? So x cube plus z cube j plus fzk differentiation with respect to z, this becomes the entire thing constant, so 0. Now yz cube, this becomes 3z square into y only, because y is a constant here. So 3y z square or 3z square into y k. So this is how to apply the operator del to a scalar function, which is known as the gradient of a scalar function. Now let us see how to apply this one to a vector function, that is divergence and curl. So guys, see here. Let me take a vector function f bar, that is f1i plus f2j plus f3k. This is a vector format of the function, right? Now the divergence of a vector function f bar is defined as, if I apply the divergence del operator to a vector function, that is del dot f bar. Here I have written del dot f bar, that is known as the divergence of f bar. It is defined as, now we know that how to take the dot product of two vectors. How to take the dot product? See, del operator means what? Dou by dou xi, dou by dou ij, and dou by dou zk. Dot f bar. So write the f bar here in a vector format, f1i, f2j and f3k. Now how to take the dot product of two vectors? So just multiply the coefficients of I, coefficients of j together, coefficients of k together. That is, here I, coefficient of I is f1, here coefficient of I is dou by dou x. So I will be taking them together, that is dou f1 by dou x, plus similarly here what is multiply with j and here multiple of j, so take them together, dou f2 by dou y and then dou f3 by dou z, right? So that is differentiating f1 partially with respect to x, means only you are differentiating whatever f1 is there here, which is a function of x, y, z. This one we differentiate with respect to x, this with respect to y, this with respect to z, and add them all. So that will be the divergence or the dot product. That is, I will write it here as f1x plus f2y plus f3z. So this is known as the divergence of a function. Now what is a curl of a function? This is divergence operator. Earlier we have seen the gradient operator. So this again is a scalar function. F bar is a vector, but divergence of f bar, this is a scalar function, right? Because here there are no I, j, k, right? This is not a vector. Now what is a curl? How to apply the operator del to define the curl? The curl of a vector function f bar is defined as, what is curl of f bar? Del cross f bar. This is the cross product of del operator and the vector f bar. Now how to take the curl? Take the determinant. Determinant of, we know the cross product, how to find the cross product, right? So take the determinant, write I, j, k. This is the standard format. Now these are nothing but the coefficients of I, j, k here for this operator del, and these are the coefficients of I, j, k for the f bar vector, right? Because f bar was defined as what? f1i, f2j and f3k. So take f1, f2, f3 here, and here for the del operator dou by dou x, dou by dou y and dou by dou z. Now take the cross product. So this is the cross product, and if you find the determinant of this one, the determinant of this one will always give me a vector quantity, because in the determinant you will be facing with the I, j and k again. So that will be a vector function, right? So this is how to define the curl of a vector function. Now remember these two important points. That is, if you find the divergence, this one, divergence of any vector function, if it comes out to be 0, the final value, divergence of f bar is equals to 0, then that vector function is known as the solenoidal vector function. Just remember the names. If divergence of f bar is 0, then f bar, the vector function, is known as the solenoidal vector function. And if curl of a vector function, if determinant comes out to be 0, if curl of a vector function is 0, then it is known as the f bar is known as the irrotational function. This you can study in the fluid mechanics. So just you can remember the names. The vector is known as the irrotational when curl is 0. Curl of a vector is 0. So let us take some examples. A vector function is given here, that is f bar equal to 3x square y I plus 3xy z square j plus xyz cube k. Now you need to find the divergence of f bar. Now what is the divergence? So how to find the divergence? Divergence is nothing but the dot product, right? So already we have discussed it, that is f1 x plus f2 y plus f3 with respect to z, differentiating partially the f1 with respect to x, f2 with respect to y, f3 with respect to z. So it will be, what is f1 with respect to x? Differentiate it. So this will be 2x, right? So 2 into 3, 6xy. So this is 6xy. Now what about this one with respect to y? You need to differentiate. This is f2, right? Now f2 with respect to y. So if you don't understand that directly, then I will write it in a explain very understandable manner. That is, this is dou f1 divided by dou x, or dou f2 divided by dou y, dou f3 divided by dou z. You can write like this. And what is dou by dou x of, what is this, f1? 3x square y, right? Plus dou by dou y of f2, 3xy z square. 3xy z square plus dou by dou z of, this is f3 xy z cube. Right? So now you can easily differentiate. With respect to x, what it will be? 6xy. This is with respect to y. It will be 3x z square. And differentiate this one with respect to z alone. 3xy z square. So finally, this will be the answer. That is divergence. R bar is equals to xi yj zk. Here R bar is known as the position vector. So we will see what is a position vector later. Now what you need to do? Find the divergence of R bar. Find the divergence of the vector, that is R bar. Divergence is nothing but the dot product. R bar equals to, see here, this function with respect to x, what will be the differentiation? That is 1. Now f2 with respect to y, that is also 1. Then this is also 1. This with respect, z with respect to z, differentiate. It will be 1 only, right? So divergence of a position vector is always 3, equals to 3. Take one more example. F bar is equals to x cube y I minus x square y square j minus x square y z k. Now you need to find the divergence of this function. So divergence of f bar is equals to dou of f1 by dou x. So this is f1, this is f2, this is f3. Dou f1 y dou x plus dou f2 by dou y plus, so dou f3 by dou z, right? Now dou by dou x of f1 x cube y plus dou by dou y of, this is f2, that is minus x square y square. Then dou by dou z of f3 is what? Minus x square y z, right? So now differentiate it with respect to x, what it will be? 3x square y, correct? Now with respect to y, this is minus 2y. Y square becomes 2y and remaining thing as it is because it is a constant. So it becomes minus 2 x square y. Now with respect to z, z differentiation is 1. So the constant as it is, minus x square y as it is. So finally it becomes 0 because 3x square y minus 2x square y minus x square y. This also becomes 3x square y. So finally the answer is 0. That is divergence of f bar is 0. Therefore, what we can say, the f bar as solenoidal vector function. Therefore, f bar is a solenoidal vector function. Now let us find the curl. Now let us see a problem based on the curl. Finding the curl value. So f bar is given as yzi, xzj, xy, k. Yz, xz, xy. Now find the curl. Find the curl of f bar. So concentrate here. Curl is nothing but the cross product. Is equals to ijk, and here dou by dou x, dou by dou y, dou by dou z, and third row will be, this is yz, xz, xy. So now find the determinant. So that will be the curl. So this is equals to I into. So I will expand it using the first row. So I into, so delete this row and this column. What remains? Dou by dou I of xy, I into dou by dou I of xy minus this one, dou by dou z of xz, minus j into, now what remains? Dou by dou x of xy, right, minus dou by dou z of yz, then plus k into dou by dou x of xz minus dou by dou y of yz. Now find these values. So it will be, that is curl will be, now see here, what is with respect to y, differentiation of xy with respect to y, x only, and here with respect to z, that is also x, because y differentiation is 1, here z differentiation with respect to z is 1. So this becomes x minus x, right? So I into x minus x minus j into, what is this? With respect to x, y. So with respect to z, z differentiation is 1. Again y only remains. So y minus y, right? Plus k into, now dou of xz with respect to x is z. With respect to y, yz differentiation is also z, because y differentiation is 1, z remains. Here x differentiation is 1 and z remains, so z minus z. So finally what is the value? This is 0 minus j into 0 plus k into 0. So it will be 0. That is curl of f bar is 0. Means what? F bar is irrotational, right? Now let us see one more example based on the curl, how to find the curl. Now find the curl of a position vector, that is R bar is equals to xi xi yj zk is given. Find the curl. So this is a gate problem, right? So if you know the answer, the standard answer, that is curl of a position vector is always 0 only. So let us prove it. Curl of f bar ijk dou by dou x, dou by dou y, dou by dou z, and here x, y and x, y, z. So expand this one, I into dou by dou z of y minus dou by dou z of, this is dou z by dou y, this is dou y by dou z, minus j into dou z by dou x minus, this is dou z by dou x by dou z, plus k into, this is k into dou y by dou x minus dou x by dou y. So finally, what are the values? This is 0 minus 0y. What is the differentiation of z with respect to y? That is 0 only, because z is treated as a constant. Here also becomes 0. So everywhere the same thing happens. Z with respect to x or x with respect to z. So it becomes 0 only. This is also 0 minus 0, 0 minus 0. So it will be 0 finally. Therefore, you can say position vector is a irrotational. R bar is irrotational. Right?